I'm the awesome tutor, and today we're going to be finishing the periodic table topic. All we have left is transition metals, maybe some things on noble gases or inert gases. Now, transition metals, first of all, where are they found in the periodic table? They are found here in this middle section. You know how you have all the groups 1, 2, and 3, 4, blah 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 blah. Well, the transition metals are here in the middle of the periodic table. And I can guess that you should know from the name of them, transition metals, that they are all metals. Transition metals are all metals. And so their properties, they all have the properties of metals. They conduct heat, then they conduct electricity. Remember, why do they conduct electricity? Because the electrons can move through the structure of the metal. And for these electrons to move, they have to be delocalized. This is actually P2, not P3, but might as well mention it. Now they're also very ductile, like metals, and malleable. Why? Let's go back to P2 again, because the layers can slide. And unlike alkali metals, transition metals are actually very, no, not that much very, but very hard. And remember, alkali metals are very soft. Transition metals also have quite a high boiling and melting point, with the exception of mercury, which is a liquid at room temperature, except mercury. Now also, the main things about transition metals is that they can form colored compounds. For example, iron oxide, which is a reddish color. So you know how other metals that are not transition metals, they form colorless compounds and you can't really tell what they are. But transition metals, they form colored compounds, and this is very useful in the analysis topic. They also have more than one oxidation state. Remember what oxidation is? Either the gain of oxygen or the loss of electrons. Remember, oil rig in terms of electrons, oxidation is loss, reduction is gain. So what do you mean by oxidation state? They can form more than one ion. For example, iron 2 forms the iron 2 plus ion, and iron 3 forms the iron 3 plus ion. And you can tell that the ions formed correspond to the name of the element, iron 2, iron 3. Another important thing about transition metals is they are very good catalysts. We use them as catalysts. For example, remember in the P1 topics, we used nickel, which is a transition metal, as a catalyst for the hydrogenation of alkenes. And that's basically the main points of the transition metals. Okay, so group 8 or group 0, the inert or noble gases. As you can tell from the name, inert, these gases are very unreactive. They are not reactive at all. Why? Group 8, remember what the group number means? The number of electrons in the outer shell? Group 8, 8 electrons in the outer shell. What does that mean? It means they have a full outer shell, and that is why they are so unreactive. Here are some examples of group 8 gases. This pen is really bad. And they are actually all colorless. Now, as I said, they're very unreactive. The transition metals are also not that reactive, but group 8 gases are much more unreactive. Alkali metals, extremely reactive. Transition metals, not really. And group 8, extremely unreactive. Let me give you some examples of uses. Helium, because of its low density, say used in balloons. Neon, used in lights or lasers. Argon is used in light bulbs. And you know, their uses usually correspond to the fact that they are very unreactive. Argon in light bulbs, or say in the extraction of titanium. Krypton is used in lasers. Now, the main thing you should take away from this is that they are very unreactive because they have a full outer shell. Bye!